So in this video we're going to look at the first of our transformations, which is a translation. When a translation is applied to an object, the object will move from one place to another place, but it will not change. So for example, two objects here. One has clearly been moved from the blue one to the red one. The object has moved, but it's still exactly the same. The orientation is the same, the size is the same. There's no other transformation being applied to it. It's simply moved. Now the easiest way to describe a translation is using vector notation, and we use what's called a column vector. And a column vector is written in brackets, one number over another one. The top number is always the horizontal movement that's going across, and the bottom number is the vertical movement going up and down. Positive is always to the right, or positive is always up. So negative is to the left and negative is down. So in the example above, if we do it by counting squares, you can see that the shape has moved across by 9 squares and it's moved down by 2 squares. So in the vector notation, we'd write this as a column vector, 2 brackets, one number over the other one. The across is 9. Going down 2, so we've got a -2 there. So here's an example of using translations. In this question we have to plot some points, and then we're going to have to translate the shape that's made. So the first thing we do is we start by plotting points. Now if you remember, when we plot points we go along the corridor up the stairs. So the first ordinate says we go along, the second ordinate says we go up or down. So we've plotted our points, we join them up with a ruler, and then what we're going to do is we're going to label our shape. So this is going to be shape A. The first part of the question says translate shape A by the translation 10, 9. That means go across by 10 and up by 9. Every point is going to happen, that's going to happen to. So we take one point, we count across 10 squares going across, and then when we reach the end of the 10 we go up by 9 and we mark where that point is going to move to. And we repeat the exercise for the remaining points. So going across 10 and up 9, and then the bottom point across 10 and up 9. Now because we know the shape isn't actually going to change, we can actually be quite clever and we don't have to count them all, because I know to go from the circle point to the one to the left of it, I go across 2 and down 2. So I can do that by counting, and I can actually mark where the point's going to go. And what I can now do is join them up with a straight line and then label that one B. The second translation says -4, -2. That says we're going to go 4 to the left and 2 down. So as before, we take any one of the points, we go 4 to the left, and then we go 2 down. We mark where that point is going to move to, and we repeat the exercise for the remaining points. If we wanted to, if we know where one point is going to go and we know what the shape is going to look like, we could just copy the shape and do it the same way as well. And we label that one shape C. The last part about the question says, how do I translate shape A to shape C? What single translation? So we can do that by counting. So the easiest thing to do is find corresponding points. So here I've marked them in black. I'm going to work out how far up do I have to go and how far across do I have to go. So I literally do that by counting. So I'm going to count my squares going up, and I see I've gone up 7, and I count my squares going across, and I see that I've gone across by 6. And I could write that as a vector 6, 7, remembering the horizontal one is always the top value.